In this lesson, I wanted to introduce to you the topic of the greatest integer function. It's not something we'll use a lot, but again, moving forward through the mathematics, you will see this again and again. So the greatest integer function is also known as the floor function. And the way that it's denoted is sort of like the absolute value bracket, but notice it's got a little bit of a floor on it, which is how we know that it's different than the ceiling function, which would of course look more like that, which we're not going to talk about today. The floor function turns every value to the greatest integer less than or equal to x. So for my integers, if I were to find f of 1, that means the floor of 1. Well, 1 is the greatest integer that is less than or equal to 1. So at 1, I would have 1. At 2, I would have 2, etc. So these are going to be all of my closed dots. These are all closed. So now what we're interested in, because I can't just connect the dots there. This is not the graph of y equals x. That's not what this is. So I'm not connecting the dots because I want to know what happens when I plug in 0.5. So what is the floor of 0.5? The floor of 0.5, remember, means the greatest integer that is less than or equal to x. So 0.5, my only integers nearby are 0 and 1. 1 is not less than or equal to x, but 0 is. So 0 is what would happen to 0.5. So at 0.5, which is around right here, my value is 0. Okay? What about 0.9? Well, that would still be 0. What about 0.1? Well, that would still be 0. So all of these values, all the way up to 1, but not including 1, because once I hit 1, then it steps up. So this is a step function, because now if I put in, say, f of 1.5, my choices are between 1 and 2. Well, the one that is less than that is 1. So from here, all of these open circle. So closed circle here, and then open circle here. So that's why this is called a step function, because it steps up to the next one. So this gives me the value anywhere, and it's the same. I can see what my value would be. So now, by looking at the graph, if I said, what is f of 4.2, I could find 4.2 and go up, and I would know that the floor function gives me the answer of 4. So this is called a step function. It's also our floor function. Try this one. It's the same idea, but I'm subtracting 3 from it, and then I'm graphing that point. So try this one and then press play to check your work. Again, it's a good place to, find a place to start. So let's say I plug in 0. If I find f of 0, I'm saying 0 minus 3, which is the floor function of negative 3, and I would just use negative 3. So at 0, I'm at negative 3, and then at 1, I would be at negative 2, etc. So there's my closed circles again. So this one's going to be exactly the same as our last function, but really all that has happened is that I've shifted it down 3. So from here then, let's say I plug in 1.5. Well, 1.5 minus 3 would be negative 1.5. And what I'm looking for is the value that is less than or equal to this. So I have choices between negative 2 and negative 1. This one is less than negative 1.5. So at negative 1.5, I should be at negative 2. So again, that's the straight line and then open circle, straight line, open circle. So this is what my graph is going to look like. And notice it looks just like that last one, except that it got shifted a little bit.